here. Sal, are you ready to join us on stage? Yes, nice. Okay, so let us welcome Sal Kimmich, everyone. We've got a jingle. It's made by AI. How are you, Sal?
I'm doing good.
Yeah? Having a good day?
So far, we just started.
Good travel?
Yeah,
Yeah?
easy enough.
Sal, with Godfly AI, is actually one of the sponsors. Now, you might think, sponsor, got the talk, that's why. Nope. Sponsors are sponsors, speakers are speakers, right? That's kind of the main selling point of the conference. Now, all talks that you see here today were voted by the community, by you guys. So, you were the first one, actually, this year, to believe in our project, and like, we sent an email, hey, do you want to? Yes, take the money. That's how it worked. So if you want to do it again, please, give me the, no. But yes, please, without further ado, what are you talking about today?
So today I claimed that I was going to talk about law and technology and bringing those together, and I am somewhat. But just a quick reference about Gadfly AI. I have nothing to sell you. We have no products. We are just a genuine community of open source developers. I bring in people who are building things that I think are interesting, only and specifically if they're not trying to make money. I have to work with production engineers all the time, and I prefer to spend my free time working with people that are doing things they're really passionate about. So I did want to come and sponsor this room because this is one of the best conferences that I've found in Europe that actually has an open source spirit. That's why I'm here. Thank you for being here.
Thank you. Thank you, Sal. Well, I'll leave you to it. You've got everything set up, and if you need anything, well, we'll be there. So thank you again, Sal Kimmich.
Cool.
Thank you.
And I was told to, part of the gamification, these things, I guess, are hiding around everywhere, and there's 15 of them, and you win something if you find them. So take a look around for these, but they handed me this to show all of you, so I assume that I also just won. So sorry, that's my alarm to tell me that I should be here, and I am. Okay, so bridging law and technology, foundations and future of computational justice. Let's jump through a couple of things that I think are important. Why am I here? As I said, I really believe in open source very deeply. I think that when I see people who understand that you can engage with the digital world as a practice and a philosophy and a verb, it makes a very, very different type of individual, someone that goes out and sees and understands their ability to change the world around them. I've been thinking a lot recently about my background in building out computational systems, particularly for medical systems. I started my career in academia building out ways to build brain-computer interfaces that could alter brain networks below the level of human attention. And I had to get that passed through an ethical review board. And I see so much technology being produced right now by corporations that do not have ethical review boards. And I think it's something that I'm considering right now, and we'll go into some use cases for that. And right now, I'm writing a book on geopolitical code, and that's really the intersection of traditional and digital sovereignty. I'm doing a bunch of interviews with anyone that I think is an expert in this field, and I'm having some of the most interesting conversations of my life. When I talk to those that are on the political side, it's always very interesting, but I'm talking about 25% to my cybersecurity network, and a lot of them are at very, very, very high risk of breaking their NDAs with the stories that they're telling me. So look out for that book, because it's going to be fascinating. Here's where I think you're here. You discovered a love of open source, and you live with the experiential knowledge of the digital commons. And I think very specifically, this is a slide that I will get into trouble with if I'm talking to lawyers, but today I think all of you would agree that open source is a verb. That is what I believe open source is. I think that you can come and you can hang out at things like this, but unless you are actively touching code and getting the experience of engaging with that world, you're not doing open source. Open source is a verb. It's a thing that you do. The thing that I think I need to convince you about is that you need to develop an individual awareness of your rights, autonomy, and data exposure. And I do think this might lead to a small existential crisis, but it's a journey that we have to take. Last year, I gave a talk here on hardware in space. And Sen Hastings, who is a prominent member of Gadfly, said, I think I could give a better talk on that subject. And they did. I would really encourage you to go, if you liked that talk last year, there's a much better version of it that goes way more into detail and is about twice as long. And I just got up on the stage, I gave my 5 or 6 slides, I sat down, and Sen gave us one of the most articulate history lessons that you can have on the subject. So dive into that, because that's explaining the kernel in space, or a lot around why it's not there. Computational justice is about ensuring fairness, accountability, and transparency in digital spaces. I think that transparency is something that we are at risk of losing unless the general society around digital sovereignty understands it. Open source, cryptography, and verifiable compute offer us the tools to make that a reality. And we need to recognize that it takes work to keep things open and secure. And if we are not aware of these things, we will lose them. Some of the core concepts that you have to understand. Sovereignty is not just about state control. It can be groups, tribes, individuals. Zero knowledge proofs, you're going to go a little bit into detail here, but you have to be able to prove something is true without revealing the data. Verifiable trust. Trust has to be replaced with cryptographic mathematical proofs in many of the contexts and architectures that citizens' data is sitting on right now. That includes you. If you're in Italy, I'll have a good example of what that means. Open source recursion, or recursive republics. This is a concept that comes from Christopher Kelty. Is the idea that we build republics out of the way that we build and communicate open source code. And I think there's a very specific argument for that being discrete and observable over the secure kernel, which I'll go into a little bit more detail on. Computational justice, as you might know it, it's the application of computational methods, including AI, cryptographic systems, and algorithmic decision-making. It tends to be people speaking a lot about fairness and algorithms, and as a cybersecurity engineer, I think all of that is null and mute if you do not have transparency. You cannot make any guarantees that there is justice if you cannot guarantee the system underneath it. It's often extremely limited to the definitions and designs of digital frameworks, but that's very much just an operational layer of trust. That is absolutely insufficient for the world that we're in right now. Sovereignty without borders. Sovereignty used to be a territorial concept. It very much extends and is impacted by the digital space now. Governments, corporations, and individuals compete over control of data, platforms, and infrastructure. The battleground is no longer land. It is considered a fourth wall of war over algorithmic influence, platform governments, and particularly cryptographic control. So when I say organizational trust, I tend to mean institutional trust. If you trust the people around you, your friends, your family, your doctors, your government officials, that tends to be institutional trust, which is just absolutely fragile and can be abused. And there is an alternative that we have developed in which you can very much verify everything if you've got enough money to guarantee that. This talk is really going to dive into that core concept, how sovereignty, cryptography, and open source governance enable that shift. Trust is absolutely necessary. I'm not saying don't trust your friends, families, doctors. I am saying when it is a large system, particularly those that require large citizenship records, these are financial institutions, healthcare records, et cetera, then we do have to move to a non-organizational trust. And this really comes into focus when we're dealing with large computational systems, particularly anything that runs on AI. That's a computational architecture. It has a unique threat vector, and the particular vector that we have to protect against now is something that I call the Jekyll and Hyde problem. How do I design a system such that the most trusted user cannot sabotage the system? Can we do that? We can. Sovereignty. Very basically, the ability to self-govern without external influence. Historically, this is territorial control. Now, right, we really have to think about identity data or personally identifiable information and the compute surfaces over which they exist. One of the examples that you're all very familiar here, which does not get enforced at all in the US, is GDPR. And digital sovereignty is that particular thing. It's the looking at how we are acknowledging, viewing, and protecting autonomy of individuals or systems. And this varies depending on what country you're in. Italy takes a very sort of common core approach to the European Union's perspective on digital sovereignty. I will say that one country that's really interesting to look at is Germany. They are much more likely to provide individual education to their citizens, and they have a dual responsibility model of taking responsibility for citizens' data and also educating their individual citizens to protect themselves. That's extremely unique. So what do I mean when I talk about verifiable trust? It means that we are explicitly replacing institutional trust in banks, governments, and corporations with mathematically proven systems. Instead of trusting a bank to approve a transaction, we will use cryptographic proofs to verify that mathematically. And that brings us into the idea of verifiable compute. We must provide mathematically guaranteed integrity by providing that, by ensuring that the end state is known and attested. One note on verifiable trust. I was just talking to someone from Switzerland earlier this week, and when we talked about the trust of financial institutions, you would think that they're highly digitally advanced in that space, but many Swiss citizens still use a thing called a yellow book, which is a physical manifestation of their financial records, and they will use that for major transactions. Which just comes back to the best way to do cybersecurity is to not be connected to the internet. Always true. So verifiability is not trust. Trust to me is one of my least favorite words. If it's a word that you do like, there's a pretty good book on this concept that's called Trust in Computing by Mike Bursell. And it takes basically an epistemological approach to understanding how computer systems are built. And zero knowledge proofs are the very, very key thing that you have to understand in this. So they allow one party to prove something is true without revealing the actual data. A really good example of this is a lot of systems that require you to verify your age online without actually having a core verification that they disclose. Secure isolation. Secure isolation is the ability to keep data and workloads separate from untrusted entities during computation. It ensures the three aspects of the security triad, CIA, confidentiality, integrity, and availability. This is something that if you are really interested in cybersecurity for computation, you've got to dive into. We're building these systems that are called confidential compute, where we are taking that guarantee and instead of operational trust, instead of even software level trust, we are putting the trust all the way to the hardware. So for a long time, I was working on ways to protect systems against like inside actors and critical threats. This is often building out honeypots, right? Building a like smaller scale fake system that a threat actor will go after instead of your real system with the real threats. This has become more difficult with GDPR because IP addresses are protected. And for some reason, even if I have a threat actor, I'm not allowed to record the IP address that it came from, which is something I would like us to fix. A trust boundary is really important here. So when you're looking at secure isolation, you must define explicitly what the trust boundary is. And this is the line where the level of trust changes between components, users, or systems. It defines which entities can be trusted to handle sensitive data and execute privileged operations. These boundaries can exist between a user and a system, a client and a server, microservices in a distributed system, and between cloud providers and its consumers. This is an idea that has been around longer than we called the kernel, and much longer than we've ever had a shell. A shell was one of the first times that we architected a trust boundary. That's why it was built. So you can look at the early history of security in the kernel, and most of the kernel's early history is really security focused. The first secure kernel was released, I think, in like 1962, if I'm correct. And the term itself really gained prominence in security in the 1990s with the rise of networked systems, naturally. And if you really want to dive into the full history of trust boundaries and secure isolation, I gave a whole talk on that about a month ago, and I'll link to that. It's definitely worth diving into, but I really want you just to understand the concepts here. And if you think that this is not relevant to you, it is. Using a VPN is you exerting a trust boundary between private and public networks every day. And if you still think everything that I'm talking about is too high level and isn't impacting you as someone who just likes to play with code on the internet, you are wrong. If you exist as a noted citizen in a country, then you are actively being impacted by these. One of the really, really interesting examples of confidential federated compute right now sits between Italy, Switzerland, and France. There was a great talk on this at the Confidential Computing Summit. And between these three countries, which is very interesting because Switzerland is not of the European Union, so they have different standards. They must ensure these 5 aspects. Can they make a complete guarantee without operational trust that there is data sovereignty, operational sovereignty, attestation, meaning that I have a full guarantee and I note that at moment of time I am looking at the thing that I want. When you have VM launches, continuous auditing of those VM instances, and extended supervision, which is very interesting, into some operations of host that are agreed on between 2 parties, such that if you have different levels of privacy expectations or data privacy expectations, that those are completely respected and that those are never violated. Great. So let's take a step back. This is something, everything that I was just speaking to you about are things that I just think that everyone really needs to be much more aware of, period. That's why I came here and gave this talk. It's something I'm deeply passionate about. Naturally, I'm also extremely passionate about open source. So what is open source? Yes, it is a verb to me. If you ask a lawyer, they'll have a different opinion. If you ask almost every single person in this room, it's going to be relative to their own experience. As long as it's a verb, I'm happy with it. But generally, when you're building code or building intellectual property, there are a couple of things that you will acknowledge, right? So copyright applies to all creative work generally. Trademark identifies a brand. Patents are protecting inventions, and open source license enable sharing. To be very clear, we do not have open source licenses for a fundamentally philosophical reason. We have them because originally code, which is a binary, could not be patented because it was considered a number. Fair use and open source. These are things that I often have to consider. Fair use generally is the protection of copyright. It's just the affirmative defense of those with lawyers. Lawyers love fair use in the US. But open source really attributes the rights of a developer and the obligations of the consumer. Most importantly, often saying, you can use my code, but I am not liable for what you do with it. The most common licenses you're probably all familiar with in this room, you've got Apache 2, BSD, GNU, MIT. I'm just labeling these out because right now there's some really interesting kind of politics that are going on with open source licensing above and beyond the open source AI license. There's a lot of relicensing and forks going on where major projects are bifurcating at this time because of license issues, because a corporation may want to take and maintain a specific aspect of the code, but the community is looking for something different. And this is going to continue to be important to citizens as many of the stewards of open source, we're talking Linux Foundation, Apache Software Foundation, and the Eclipse Foundation, for their critical projects, they are now and will be requesting that you have government ID verification to contribute to them. That is one of the major reasons why you're going to see forks and relicensing. Open source governance, it comes in 6 flavors. There's the idea of a do-ocracy, where decisions are made by the people that do the work. These are the kinds of systems that I enjoy working with. There's the benevolent dictators for life, and there's a couple of really good examples of this. So Python was, and still to some degree is, a benevolent dictator. If you've ever worked with the Clojure language, that's a core maintainer, and they're doing that by choice. Self-appointing councils or boards, this is adding a little bit of bureaucracy to the systems. Django works in this way, and formal electoral governance is also a very key version of this. This is how Debian works. NeuroDebian is the first open source community that I ever got involved in, and I think it's why I am so like pure open source, because I didn't realize until I got to Kubernetes that for some people open source is just a job. But it is to Kubernetes, not to Debian. Corporate backed. A single company maintains control over the direction of a project and its resources, particularly the financial resources of the maintainers. Google often is a core maintainer for things like this, including Kubernetes. And foundation backed, which typically is going to be it can be one of the previous governance models, but it's more likely to be a corporate-backed project that is going to be shifted to a steward. If you're really interested in what this looks like, within the Linux Foundation, there is a group called Chaos where we do data science over these kinds of problems. Right now, we're doing a really interesting study looking at how contributions and communities change pre and post being intaken into a formal stewarded group. So we're looking at, and I have to finish the scripts for this, but we are looking at Apache, Linux Foundation, specifically CNCF, OpenSSF, and Eclipse. And I think that's going to be fascinating. We know anecdotally that when projects get intaken to foundations, they tend to have more variety and more variety in type of person that contributes and a stronger, larger contributing base. And this is really what I want to dive into right now. How do I only have 3 minutes? I'm going to go super fast. You need to understand that open source is political, the kernel is political, and it always has been, and you can only have an apolitical view of open source if you don't understand the history of it. So understanding the secure kernel, know that it's been around for 60 years, and if you want to look at that, I have a whole talk on that you can go find. But I want to jump into cryptography because it's incredibly germane to this moment in time. So in 1970s, there was the development of the first data encryption standard, 1980s, public key and pretty good privacy. which we still use. 1991, Linux kernel was released. 1994, introduction of DES into Unix. 1997, we said, whoops, that was not secure. 2001, Linux kernel 2.4 introduces devrandom and urandom. This was really good to help us with cryptographic functions. 2003, CryptoLuke was introduced. 2004, Linux Unified Key Setup was introduced, which really allowed end users to be able to utilize these. 2005, dmcrypt comes into place. 2006, eCryptFS comes into place. And 2008, full disk encryption becomes default in Ubuntu. This is the first time where you as an end user had easy access to being able to control and encrypt on your own. But it's been changing. So in 2014, there was the introduction of kernel lockdown and secure boot enhancement. Secure boot is absolutely essential when we're talking about sovereignty. 2017, inclusion of the adiantum algorithm for lightweight encryption. This is useful. And in 2018, the NSA introduced the spec cipher, which was extremely controversial and led to its removal. 2021, Linux kernel 5.1 enhances secure computation. This is where we're getting into the underpinnings of things like SEV or anything in which you have hardware level guarantees about your attested state. It really unlocked the ability to do federated or confidential federated compute. 2022, remote attestation is formally integrated into the Linux system. And 2023, we have a Rust implementation for these cryptographic methods. And I always have to remind people that yes, Rust is memory safe, and it removes an entire vector of concerns, but it does not mean you're developing securely. It just removes a specific type of secure threat. So if you want to dive into this, there's a really, really good blog on this, I think, for beginners into this concept. But the modern Linux encryption is allowing us to really focus on compute platforms, which offer really unique security vectors. So you want to pay attention to Intel SGX, AMD SEV, and ARM CCA. All of the talks that I've given in the past year really focus on that, and we rely on zero-knowledge proofs for multi-party computation. Basically, the thing that you need to understand here is everybody's super worried about using the cloud for multi-tenant if you can be concerned that a workload identity can be an issue. And some key points of this are this is really what that form of computing is doing. I stole these slides from Axel Saab. He is a field CTO for Red Hat, and I emailed him just yesterday. I was like, can I steal these slides again? Because they're so good. So these are some key examples if you want to look into really what the cutting edge of this type of security is. And the digital sovereignty is the part that I find really compelling. And here's another side from Axel that is equally interesting and important, and it comes from their use cases for CC. Really understanding that this is a combination of hardware and software. So when I was working over the portfolio of projects for confidential computing, I was working with chip providers, software providers, and platform providers. It is the only foundation within Linux Foundation where you have all three of those. So I hope that in a whirlwind argument, I brought you to a slightly better understanding about how we must ensure fairness, accountability, and transparency in digital spaces, understanding open source cryptography and verifiable compute. And just as it has always been with cryptography, if you do not argue for transparency, you will not get it. Now, Gadfly AI, we're a collective. We're just a bunch of developers that do things because we care. We also make open source zines. And this year, so each year, every Gadfly gets to choose something that they think is important. To me, I had a fun one, and I said I want to run a bunch of awards. So I'm going to run through these super fast because we're out of time. I'll skip these, but this is good. Look into Shiv Integer if you want to look into licenses being used for absolute chaos. It's a lot of fun. It's an art project. and I'm going to skip over all of these. I'm going to talk about the 9 awards that we're going to offer this year, and I want you to keep yourself in mind or someone you know. So in open source, as long as you have a project or a person who works with projects with open source licenses, I want to award projects that play with things like playfulness, science, accessibility, ethics, art, safety, togetherness, knowledge, and leadership, which I just got the video done for this morning, so it's not up yet. If you are interested in learning more or joining us, if you've got a project that you're working on and are looking for a community, that's what we do. As long as you're not trying to sell me a product, you can join. And lastly, if you are interested in learning more about this as I write up this book, or you have someone that you think I should interview, particularly more Italian contacts, because I have interviewed so many French people, which is kind of natural, but I would love to interview more people in Italy, which is part of the reason why I'm here. Do get in touch with me, but mostly join Gadfly if that sounds like something that's cool to you. I'm in your time zone, easy to do.
Thank you, Sal. Thank you. No, please stay. So we know a few people, so there's going to be presentations, of course. We've got 1 minute for a question. So would anyone like to ask a question? Also be reminded that it is part of the gamification process, which means you win points, which you can turn into other things. Any questions? Yes, we do.
Where?
We got one there.
Thank you. Thank you for this very great talk that is a nice breaker taking us at the summit without oxygen in the morning, so cool. This is the kind of question that probably a prompt or a Google can resolve, but I prefer the human-to-human factor. So do you have touched also the trust, the execution environments thing in the last few slides? Do you know if there is any open source hardware project for the trusted execution environment right now in the space?
Yeah, so trusted execution environments, TEEs, really that's what I'm speaking to. So you've got 3 core options. So you've got TDX, which has converted to SGX now. That's like Google's hardware base. You've got ARM CCA. That's mostly around embedded architectures. Particularly, that is going into your self-driving cars and all of those systems. So it's impacting you right now. So we've got, and NVIDIA also has, I'm missing one of these chips right now, but I don't work for the Linux Foundation, so it's not a problem. But NVIDIA has done this with their H100s, so you can get confidential GPUs, which has unlocked our ability to do this with AI. Which is very cool. But go and look at the Confidential Computing Consortium. It's where all of them live. And just to note, the Linux Foundation, yes, it's a foundation, but it also has completely open office hours, as far as I'm concerned. That's how I use it. So if you're really interested in this, go and check out the sub-foundations that matter to you. Go and look at their recordings. And if you have a question, jump on the live call. Ask them about it. They will answer.
Thank you very much. We've got a very squeezed time for another question, quick one. Thank you.
Hi, thank you for the talk. So I was thinking, there are many companies, huge companies, that should be trustable or verifiable, but then get huge leaks, get a hole in their privacy or security with sensible data lost. And so what do you think, there should be a way to have some way to verify this company from some external sources? Or what do you think about that?
Yeah, so right now, I mean, the proliferation and usage of cloud has been a major issue, because what most people do not acknowledge is that even if you've got every security lockdown that you can possibly have at the software level, if you are using one of these major cloud provider platforms, there are security vectors that come from the operating system up. that you would not even have observability of unless you are doing hardware attestation. So that is why there has been this massive convergence around compute and privacy for every major chip provider, and that is not going away. Right now, it's only sitting largely in regulated environments because it costs more money and it has some latency issues. I will say one of the things that's both leading this and being a pain in this area is regulation. So a great example of this is Chase Bank has been running simulated transactions for over 2 years, billions of transactions over a completely attested confidential system. They cannot put that into production because in the US, there is a regulation called break institutions. We have created a system which has security that cannot be broken. We can provide you a guarantee, inspect it.
Much. Thank you, everyone. Sal, please remain on stage with me.